example 2 in 10.1 is much the same, except it's subtraction instead of addition, just to make sure you read that function notation carefully. We're going to get right into the actual function itself. Now, you have to be a little bit careful because addition, the order in which you add doesn't matter, but the order in which you subtract makes a really, really big difference. And I want to emphasize that f minus g of x is not the same thing as g minus f of x. So make sure you read that carefully, and moreover, understand that really what this is telling us to do is to take the function f of x and subtract the function g of x. So that means that we could immediately say that h of x is going to be function f, which is the square root of x minus 1 minus function g, which is x minus 2. Now, those brackets are really, really important because we're subtracting the entire function, not just the first term. So we would say that h of x is the square root of x minus 1 minus x plus 2. Really important that that negative distributes onto that bracket. So same thing as the last question. We have this table of values where we could quickly identify several different points. Now, important that this f of x is a radical function, and it doesn't exist when x is less than less than positive 1. So when we talk about, what is the value of f at -1 or -2, it's undefined. And again, I do want to reveal those graphs right away, that if we look at f of x, and I won't screw up the colors this time, in blue, we see that it does have this endpoint at 1, 0. Now, this is part of the reason why we saved chapter 10 for the end. Hopefully, after chapter 2 and chapter 1 and all the transformations we've done, you're pretty comfortable with recognizing that that's the graph of the square root of x moved 1 unit to the right. And that can help in graphing these things. G of x exists everywhere. And all that's happening here is we're subtracting 2 from the input to get the output. Now, for h of x, it is as simple as taking the value of f and subtracting the value of g. But what if f doesn't exist? If a piece of your sum and difference function doesn't exist, then the entire sum and difference function doesn't exist as well. Because f of x is undefined at basically everything less than positive 1, h of x can't exist there either. And really, I think that shows in the algebra, because the square root of x minus 1 is present in that equation, the radicand, what's inside that radical symbol, must be greater than or equal to 0. So this, x is greater than or equal to 1, becomes the domain of h of x because it still contains that radical piece. For every other point, we will just subtract. So 0 minus -1 gives me positive 1. 1 minus 0 gives me positive 1 again. 2 minus 3 gives me -1. 3 minus 8 gives me -5. And we do end up with a pretty strange, maybe unexpected graph. And part of that is because it is a bit of a strange function. It certainly is radical because the radical symbol is there, but because we have the variable inside and outside of the radical, the shape is very difficult to predict. You don't really need to be able to look at f of x and g of x and predict the shape of h of x without technology. So please do make sure you have your calculator, because you could type in that h of x as y1 or whatever y you wanted, and then you could see what that graph looks like. That does make finding the range a little bit difficult because we do have this little point right here that is higher than any other point. But I'm not sure if they ask us for this. If they do, we'll take a look and we'll find it on our calculator. Okay, so we sketched the graphs. They want us to state the domain of h of x. We have h of x right there. Just one more time, I want to point out that this is the idea that the radicand of an even indexed square, or even indexed radical, must be non-negative. So it has to be 0 or greater. And that lets me know that x must be greater than or equal to 1. And then the only thing I'm going to add on to make that a domain is we'll say what variable we're talking about, the restriction, and then what number system it has to be an element of. Any real number is pretty consistent in math, in math 30. All right, then it says use the graph to approximate the range of h of x. I'm not a big fan of approximating if we don't have to. If I was going to approximate this graph, we'll pull it down there, I might say that that's at 1.2. Looks like it's about a fifth of the way through there. But we have our calculators. So we might as well remember or retrain ourselves into how we can find those points. So I'm going to put in my function, the square root of x minus 1, make sure I close that bracket. I'm going to subtract x, I'm going to add 2, and then just to make sure it looks like we were looking at, I'm going to go to zoom standard. You can see the function up here if you missed that. And the calculator doesn't do as good of a job as we might want. It doesn't really show that kind of upward point there, but we can still find the largest value of this curve by doing second trace maximum. So when you do the maximum, the left bound has to be on the curve. So we have to go until we get to x equals 1. That's fine. Look at the y values. Do you see how it's still going up? That means we're not to the right of it yet, But as those y values start to go down, we know that we've gone past the maximum, and then the guess doesn't particularly matter. And I get that the maximum, oh, that's pretty friendly, right? It's 1.25 and 1.25. Now, by using our calculator, we know exactly where that happens. Oops. So when I do talk about the range of h of x, because we've used our calculator, I can now say that y exists less than or equal to 1.25, but it is any real number within that restriction. Don't get too, used to the idea that you're not gonna have to use your calculator in chapter 10. That's not the case. Your calculator is a fantastic tool. Really, all that we're doing that the calculator can't is writing out these sum and differences to make sure we know exactly what function that we're examining.